Hello, everyone. Indeed Inspiring is back again with a great and educational session. So today we have Mr. Vikas Kodak. We are delighted to welcome Mr. Vikas Kodak, sir, a learning engineer as Deutsche Bank and a seasoned technical expert. His core strengths include Java development, performance optimization, clean code practices, and building maintainable software systems. So welcome, sir, and I would request Vikas, sir, to start the session.
Okay. Thanks for the introduction and let me start. Please let me know once the screen sharing is visible.
Yes, yes, it's visible.
Okay. Uh, so as we already have my introduction, I won't go much into that again. Just like to introduce the content. The content that we would be seeing now is most of that is taken from a book called Effective Java. It was written by Joshua Block, and we, since its inception, we have few updates to the book as well. So it is a very good read among the software developers, Java software developers, and it points out basic Java mistakes and low-level code optimizations that we can do to make our code better, more secure, and more performant, and effectively leading to less bugs in our code. Uh, okay, so I wanted to have practical code examples in this session. We won't be going into theory much, but we would be looking at few examples, checking out what is being done, and then figuring out what is the problem in that code, and then finally how we can fix it. This is one of the basic practices that we usually do in the corporate, and we will be doing the same today. I had few examples, and once we are done with those examples, I had a small activity planned, and if possible, we'll do that. If not, then we'll conclude the session. Uh, okay. So one of the prerequisites for this session is your familiarity with Java. Uh, we won't go in depth in Java, so advanced Java concepts, they are not required, but you should be familiar with basic Java, right? And I believe most of you have already experienced, written few code snippets in Java and already ran them and seen how Java works, how the code works. Okay. So this is one of the example problem that I faced while writing code in Deutsche Bank. Uh, we pushed something similar in production, and we were getting uh, results which were very dubious. We were not getting constant results, which was expected. So what we are doing here. So from the function name, we can see that we would be applying filter on a stream of data. Obviously, we have an example stream here. In production, you would take it from your parameter. We have the final list array which we would be returning. So this would basically be the filtered data that we wanted to filter. All data, I have a sample example here where in our list we have from integer 0 to 1000, and it will suffice for our example and what point I wanted to put forward. Okay, so how we do this is we go through each element in data. That is done by stream. We apply parallel because we want to do the filtering operations parallelly on this array. And then we apply the filter condition and then the filter predicate. The filter predicate is obviously an example. This is not what we do. So what we are doing here is we are checking for each element in my integer stream to be even. And if it is even, we are adding all these elements into our final list array. So there is a small bug here, possibly something that we can often miss because of what we are doing. So we wanted to make our code efficient and we tried that, and then we left the bug for our future selves to identify. So if anybody can guess or try to guess, and within a minute or so, we will be looking at the problem. What is the problem and then how we can correct it. Okay, let's start. The problematic thing here, the very first thing I can point out is dot parallel. What this does is it allows us for the operations that we are performing on the stream to happen parallelly. So we have these threads which get spawned up and then run this filter predicate on the elements of our array parallelly, and then all of them are combined here in the for each operation, resulting in the final list array which is getting populated. So the problem here is dot parallel. So what we are doing is we are taking from the all data list certain blocks of data, performing filter operation on that parallelly, and we are pushing the result if it satisfies this condition into the final list array. So what happens is the addition of the elements in the final list array happens parallelly, and list by default is not thread safe. So if you operate on a list integer, if you are adding elements, if you are removing elements in a parallel environment where you are working with multiple threads, this could give rise to unexpected problems here because it is not thread safe. It was meant to be run only on the one thread. So what happens is we have, let's take for example, we created an executor service and it runs on 5 threads. So we have our integer array divided into 5 parts. So 1,000 elements gets divided into 5 parts, and each of those threads are uh, doing the operations parallelly. So they find out the odd even integers among the list and then tries to insert that in the final list array. Now each of these thread is doing that operation. So one thread won't have idea about what other thread is pushing into the final list, right? So this is the problem here. The solution to this problem is using a thread safe list. So Java provides solution to this problem. We have collections framework which can help us here, and we have a synchronized list which is an offering, which is an API from Java in collections framework. So that is a thread safe list. We can use that in a multi-threaded scenario and it would give us the result as expected. So simply having instead of new array list, we can have collections.synchronized list, and that would be the solution to our problem. So So that's the first example that I had for you. The learning from this example. So we should be very careful of the objects APIs that we are using when we are working in a multi-threaded environment, right? All the elements that we use, they have to be thread safe. If not thread safe, we have to ensure that the operations that we are doing on them is thread safe. For example, uh, getting an element from the array list in a multi-threaded environment is okay because we are not modifying our list. So getting the element should be fine, but inserting, updating, deleting, removing, all of those are not permitted. So we should be very careful while doing operations on a when we are working on a multi-threaded platform. Okay. Uh, let's look at another problem. Uh, so this is a small code snippet from Effective Java. You can read the book. It is available publicly on the internet. You can download it and go through that. It is a must read for all the Java developers. So we'll again go through this problem. So what are we doing here? We are summing up all the integers from 0 till the max value inside our sum variable, and then we are finally printing the sum. This looks simple, right? Not dangerous at all. Easily, this is working and it should be fine. But yeah, we have a problem here. And the problem to this solution is also very small. It is often not apparent to us, but when we are using Java, there are often more than one ways to do things, often more than one options for us to choose from. And it is there, if we don't understand the options in detail, we might be leading our application to use significant resources and significant memory. So I'll straight away go to the solution. So this is what we had. I have added small changes to this code so that we can track down the time it takes to execute. So we had a wrapper object over long primitive long initialized with 0 value, then going over loop from 0 till the max integer value, and then adding it in our sum variable. And then we are finally printing it. So you can see that the execution of this code takes 7.5 seconds, around 7.5 seconds. Yeah, ideally, it should not take that much time. But what is happening? Okay, so let's look at the solution first, and then we'll come back to the problem and what is actually happening in the first snippet here. The solution is very simple. We change from boxed primitive long to primitive small long. And what this does is it reduces the runtime very drastically. You see that we simply changed from boxed primitive to a primitive, and the execution time is around 1 second. So that's 7 times performance optimization that we have found. The change seems very simple, no harm done. The result is same as well. But what is happening in the backend? So when we are working with boxed primitive variables in Java, you might have heard while working in Java that object creation is one of the most memory intensive and performance intensive process in Java. We should always be we should always be critical of the objects that we are creating in Java. If we want to create it, we should use lazy initialization. So this is also a very popular term in React.js, where we are creating the components we want to render only when we want to render. And not otherwise. So here also we are creating a boxed primitive. It is a wrapper object over primitive long. And what this does is the creation of this boxed primitive object in a JVM is a memory intensive and resource intensive process. What it means is it takes time to create a boxed primitive variable. And then on subsequent addition, so we go from 0 to max integer value. Every time we do this operation, it is creating one more sum variable, which is again a boxed primitive ergo heavy operation, adding to it the value that we want to append. Again, an operation that we do as a part of our code. So the thing that we are doing extra here is creation of a boxed primitive object. Now keep that in mind. So we are creating a box primitive object around 2.2 into 10 raised to power 9 times, right? I believe the integer max value is somewhere around 2 into 10 raised to power 9. So we are doing that 2 into 10 raised to power 9 times. That is heavy operation, and that is what is leading to the extra 6 seconds that we see in the runtime difference, right? So when we shift from box primitive to long, what this does is this is a primitive object. Creation of this primitive objects is very efficient in Java, and it is advisable to use primitives over boxed primitives unless you specifically have a need for them. So this removes the creation of a heavy object and thereby giving us the efficient runtime that we expect from our code. So what we learn from this? Wherever possible, always use primitive data types. We have integer, we have long, we have double, we have many other primitives type, and that's what we should always use instead of the box primitives. Okay, I'll take one more example. Now this is a complex example. Again, this is taken from Effective Java, a book which I expect every Java developer to read. Okay, let's go to the problem, right? So here we can see a simple stack class. So we are creating a stack class. We have initialized elements that we want to store of type object, so we can insert at runtime any object that we want. This is the size of our stack, the initial default capacity of the stack, and then we are creating an object array of initial default capacity so that we can store elements in that. Pretty straightforward. So when we want to put, so stack is a data structure which follows LIFO principle, last in first out, right? So what happens? So when we want to push something in our stack, so we are pushing the element, effectively adding the element at the last position in our array. So we have size, which determines how many elements I currently have, and then at size plus plus I add the element that I wanted to add in my stack. So stack, as we know, supports pop operation as well. So how do we go for pop? We don't want to pop anything if the size is 0, right? There is basically nothing left for us to pop, and then we can throw a custom exception that we want. But if there is an element to pop from the object, the stack array, so what we can do is we have to remove the last element. Remember the LIFO principle that we talked about? Last in, first out. So the elements which are added at the last gets removed first. So we have to start removing the elements from the last. So what we do is we return the element and we decrease the size as well. So this basically decreases, this proposes that we have decreased the elements from our stack. Okay. Ensure capacity, this is a utility function which we don't have to go in detail, not relevant, but yeah, an optimization and a code level efficiency that we need to have. Okay, there is a problem here as you expected in this code, yeah, and it is a memory leak. So what is a memory leak? In Java, when we create objects, the objects are created in the heap memory. Now, I believe you are familiar with this terminologies, heap space and stack space. So, heap space is where all the objects created at runtime in Java by JVM are stored, and then stack space has the reference to these objects so that we can operate on them in our code. Yeah. So, whenever we are creating an object, it gets created in the heap. And how do we access that those objects? It is via a reference variable that gets created in the stack memory. Now what happens here? We will go into the pop function. What this does is it is simply reducing the value of the size variable that we have initialized, which determines that we have we have popped the last element from our array, right? We no longer use that. But the problem here is we are not removing this element from our elements list. Yeah, the element is still present in our array, but it is not usable because we won't be removing them and we have no way of getting it as well, right? Stack as a class by principle does not allow that. So what should we do? How should we solve this problem? Yeah, so we can add 10 elements to our array, and now when we pop all these 10 elements, we are not deleting them, right? We don't have a use for them in our code, but the objects are still present in our heap and using the memory, right? And this can lead to memory spikes in your problem, and eventually your system will go out of memory and you will be needing restart of your application to so that JVM will deallocate all this memory and do a fresh spawn up of the heap space. Yeah, so how should we solve this? So when we are reducing the popping the element from our array, we can store that in a result so that we can return the result. Pop returns the result as you see in our function, and we can have elements of sizes null, and thereby what we are doing is we are removing the reference that we have created in our stack to the heap space object that we created, and thereby now we allow Java to effectively garbage collect this object that we have created here because it doesn't have any reference to that variable, and therefore garbage collection in Java can run and then clear this object from our heap space. So this removes the memory leak. So garbage collection is a process in Java which removes all the unused objects, basically the objects which don't have any references in the stack variable. So objects which are not reachable through your code. So it takes all those objects, removes it from the heap space and giving you a free space for new object creation in Java. So this ensures that uh, we don't have references to the unused objects, and thereby we allow Java to garbage collect them and then free up some memory for us to use in our application. Okay, what the lesson to learn here is we should be very careful of memory leaks. The objects that we create, we have to make sure that once we are done with them, we don't have any reference to those objects. So we can have garbage collection take care of those objects. If we don't do this, our memory consumption for our application would go up. And once it goes sufficiently high, we would be needing the restart, which we don't want in our production application. We don't want our application in production to go down on a weekday just because we were not able to handle this small problem. Yeah. Okay. This is also one of the most famous topics among the Java coders, and this is that. So there is a debate here, right? There are few cases where composition as a principle is better. There are cases where inheritance as a principle is better. Now, I believe you would be knowing these principles. They are very basic, low level stuff, low level principles in Java. I believe every Java coder would know them. The point being, why should we prefer composition over inheritance? A very famous example that Java itself provides us that in turn supports this principle is the stack class. So stack class in Java is the best example of this problem, and the problem being we should not use inheritance everywhere. There are places where it is useful, but yeah, only in those places we should use, and we should not use them willy-nilly. Yeah. Why do I say that? So stack class extends vector to get a array where we can store the elements in the stack. Now we have vector class which gives us few operations that we can do on array, and stack doesn't override them. Stack allows those APIs from vector class to get inherited to anybody who will create an object of stack class. That could be very dangerous. For example, stack by principle only supports pushing the element in the array and removing the last element. Yeah, what can vector do? One example, vector class allows us to remove element in our array at any position. Let's say I have my stack of 10 elements, and stack principle allows me to remove the element at the last position, but vector class allows me to remove elements at any position. Yeah, I can remove element at third position, fifth position, which defies the principle of stack, and that is very dangerous. Yeah, we are giving an API for end users to use without actually seeing the scope of what actually should be given. We are allowing users to use something more, something which is in violation of the principle that we intended to do. Yeah, so we should always analyze where inheritance and is it actually usable, and then we should replace it with composition. Now, for example, in the stack class, if instead of inheriting vector class it was using vector class as one of its fields, then we would not have this problem. Yeah, because we would not be exposing operations that vector API exposes via stack API. So that reduces the technical problem and everything along with it, and then we would have stack class perfectly usable with end users, a Java API that anybody can use without exploiting the principles of stack. Okay. I hope the few examples that I was able to share, they were able to provoke some thoughts of when you write code in Java, how you should write them, and what are the principles that you should basically be adhering to when you write code. Yeah. So let's go over them once again and then we will conclude our session. First thing, we should be very careful of doing operations when we are working on a multi-threaded environment. Yeah, all the fields that we use in multi-threaded environment, they have to be thread safe. We can't use non-threaded thread safe fields or classes in a multi-threaded environment because they would give unexpected results. For example, the hash map class that we can use is not a thread safe class. So if we are using, let's say, 5 threads to insert elements in our hash map, it won't work. Yeah, because one thread is inserting an element, other thread doesn't even know about that, it is again inserting, and that won't work. What we can do is we can use concurrent hash map. So it is again a collection API. Collection framework provides us that, and it is a thread safe variant of hash map that we can use in our code. Okay. Second point, wherever possible, we should always use primitive data types. The operations on primitive data types is very quick. The creation time of those objects is not as much as the boxed primitives. The problem with using primitives is that we can't have null. Primitive objects in Java don't support null. If we are initializing them without providing any value, they would by default take 0, and you would have to handle for these cases where you are expecting null in a primitive in your code. Java by default can't handle that. Okay. The third point is we should always eliminate obsolete object references. What this means, as we already discussed, heap space stores the object, stack space stores the references to those objects, and we use these references in our code. So any object which is not usable henceforth, we should be deleting the references to those objects, and thereby we allow garbage collection process to collect these objects and then remove them from our heap space. This allows us to get heap space memory continue to be used, and it prevents our application from going into out of memory error, yeah, which is a very nasty error. So keep in mind, whenever you are creating objects, always deinitialize them so that Java can take care of the garbage collection and then provide you with memory that you need in your application. Yeah. Another principle is to prefer composition over inheritance. As I said, take it with a pinch of salt. There are always cases where inheritance is a better option than composition. In those cases we have to use inheritance. But why composition? Yeah, so as we went over the example of the stack class, so stack extends vector, thereby inheriting all the operations from the vector class, and then exposes it to the end user some of the operations which by principle stack should not do. Yeah, so that becomes a dangerous precedence. If we would have used vector as an object inside my stack class, we would not have exposed all those additional operations and we would be safe. Our stack class would basically be usable as a Java API. And if you go over the stack class, right, in the Java documentation, you would see Java itself not promoting you to use stack class, yeah, because of this problem. The another thing that we should always do, so this is a very basic principle in Java, that the accessibility of the class and members, right? So what do I mean by accessibility? You know, in Java we have public, private and protected. These are the access identifiers of the objects or the classes. So class can be public, and the objects or the field variables that we create in the class, they can be public, private, protected. We have different scope for all these variables, and we should be judiciously using those identifiers. Wherever possible, always use private, because this encapsulates what you are doing in your class well. You are not showing to the outside world what is happening in your class. Yeah. So if you want to expose those variables as an operation that your class provides as an API, what you should do is you should create public methods, and then you can expose those variables. For example, the getters and setters in class in Java, right, in a class. So what you can do is when we are trying to set something in a class variable, we can check for out of bounds values. What if we want to store only positive values? We can check for that take only positive value, and if a negative value comes, we can throw an exception. So we can do all these type checks, all the business logic checks that we want before we actually set the variable with the value that we want. And this prevents application going into unexpected states. This prevents our class uh, so that it doesn't behave unexpectedly, so that it is always working as we expect. Yeah. Uh, Minimize mutability. So mutability is a concept in Java, and it basically means, are we allowed to change the values in our objects or not? And by default, as a principle, the objects that we create should always be immutable. We should prohibit working with immutable objects, because mutable objects can change, and if we don't expect our variables to change, we might go into unexpected states, and our application would behave unexpectedly and we won't know what happened. So the principle here is to always use final when you are declaring any object. It basically doesn't allow you to reinitialize your class, reinitialize your object, and it only will ever have one value. And you would be sure that whenever you access that object now, it only has one value and it won't change. So this also prevents going your this also prevents unexpected behavior from your application. Yeah. uh, Yes, so that's all that I wanted to share. I believe they are very simple examples, but yeah, they do contribute to how your application uses memory, how your application uses resources in runtime, the time complexity of your application, the space complexity of your application, the overall behavior, right? You wouldn't want your application going in production with these small bugs. And as we saw, we we need to add few cases, few small modifications to solve all these problems. Yeah, but they are not apparent in the first look. So we should always be careful of what we are writing, and be judicious on what should we really use this, should we really create this object, should our objects really change values, all these things. And one of the best books that can guide you on to do's and not to do's on Java is The Effective Java, right, by Joshua Block. So it is a must read. And with this, I finish my session. So that's all I wanted to share. Thank you.
Thank you. Thanks a lot for this insightful session, and specifically those who are fresh graduates. It was something which was very new. Like normally, the kind of education series we have is uh, learning programming or solving some problems, but this is something which is actually required when you are engaged into some project and you are particularly working on some specific features or modules at that particular time. This is something optimization is very much required. So I would request the viewers to pause, watch it again, go back, watch it again, and try to understand, try to replicate the things which are not replicate, probably try to figure out if you are doing some maybe hobby project, or maybe you are engaged into some product development activity. So try to find out, figure out where you can utilize these concepts. So that's what I would recommend the viewers. And once again, thanks a lot. Vikas ji, for coming in and sharing your experience, your knowledge, and expertise. Thank you very much.
Thank you. Thanks to you as well to give this platform so that I can share my experiences. Yeah. Thank you.
Most welcome. Yeah.